Hello and welcome. This is Sal Subness here with SS Multimedia. Today, we're going to be talking about making and testing generalizations.
Alright, so let's talk about our objective. So objective is understanding how to create and test generalizations. So creating is, of course, making, right? We should all know what that means. So understanding how to make and test. Test means, like double check, I suppose. Again, no, I'm not talking about this kind of check. I'm talking like if you, I'm sure you've probably heard your parents say this, like if you go to Starbucks and be like, hey, double check that order, something like that, right? If you get 4 plus 2 equals 6, you could test that theory by doing 2 plus 4 equals 6. That's what testing is. Okay, I'm assuming you would know that. And then generalization. This is something you might not know. Might know, you might not know. I don't know. Okay, I said no in a lot of times that sentence, but that's okay. So, what's generalization? Okay, so in short, it's a theory. Okay, in short, it is a theory. And it's like a proposition. I don't know how to explain it. So, if I have, alright, so all of this stuff, these are all generalizations. So I could create a generalization saying that, let's see, any square cut in half will create a rectangle. And I could test that by drawing a square, cutting it in half, and saying, okay. And you could just check it by doing this. That's a rectangle. That's a rectangle. Right? So, that's how you can check. That's like how you can check. So that's like actually an example. Basically, that's how you can make and test a generalization. So, step 1, what did I do? I created a generalization saying that any square cut in half is a rectangle. I tested it by doing that, and I came to the conclusion that my generalization is true. Okay, some generalizations might be false. Let's go ahead and get started. So, here we have an example here. I spent hours trying to draw this square. You can see it's finally almost perfect, so that's okay. And now we're going to be talking about how to solve it. So I have a generalization that says that any square divided in two diagonally will result in two isosceles triangles. Again, in case you're wondering, before we start, an isosceles triangle is a triangle with two sides equal. So this is A, this is A, and this is B. Right, so two sides are equal. So these two sides are equal, and this one is not. So my theory is that we'll get two isosceles triangles. Okay? So it goes diagonally. This would be a regular line, and this is diagonal. Right? So we're just gonna cut it like that. So, of course, it might not be the best, but I'm gonna try. So I'm gonna take green and I'm gonna cut that in half diagonally. And my generalization that it will result with this one, I'm gonna call this triangle A. And actually, no, I'm just gonna call that. So I'm gonna write down vertices actually. So A, B, C, D. A, B, C, D. Okay? Triangle ABC. So triangle ABC will be isosceles. Right, no. Yeah. Triangle ACB will be isosceles. I'm gonna write iso. And then triangle CBD will be isosceles. Right? And ABC is this one, right? It goes from A to B to C. So this one is ABC. ABC. And this one is CBD. Okay, so that's how we're going to keep track of what we're calling. Now, how do I test this theory? So, okay, I've created, if you go back to our objective, you know that, okay, step 1, I've created the objective, created the create generalization, okay? Step 2, okay, and I'm going to erase all this other stuff here, okay, because I'm going to need that space, okay? Created a generalization. Step 2, draw it out. Draw it out. Okay, and which is the thing we just did. We drew it out and we named it, so now we're all set to go. What are we set to go to do? We're set to test the generalization. Okay, so how do we do that? Well, you're going to check. This is an isosceles triangle based on what we think, right? So that is very, very bad line. So I'm going to retry drawing that line. This time thicker. Okay, so remember, this might not be the straight, but it'll work. So now we're going to test this side. Okay, these two sides are equal, right? How do we know? Okay, because each side of the square is equal, right? All those sides are equal. All equal. 4 sides of the square is equal. That's like a big feature of a square. So that means that if these two lines are equal when they're a square, they're going to be equal when they're a triangle, because this length, 1 centimeter, isn't going to change if it's in a square or a triangle. Right? I'm not saying that's 1 centimeter, but that gives you an idea. So those two sides are equal. Now this is like the big part. If this is equal to this, to those two, then that means it's an equilateral. If it's not, then it means it's isosceles. Okay? And I'm going to look, right? So, let's see. How much is that? Right? So I'm just going to draw it a couple of times, because usually it actually helps if you just draw over it sometimes. And now you can picture it, right? And you're going to want to look at it diagonally, right? And when you look at it diagonally, you'll notice that this one is not equal. It is less than. So this one, these two combined would be more, but this one is way more than this AC line. So ABC is isosceles. So that theory is correct. Next, let's see CBD. Okay? Now, if you realize this is a mirror. This is a mirror image of this triangle, right? These two are equal, right? And this one is the same line. So, again, it is isosceles. So, my generalization is correct, right? So, that's actually pretty cool. So, that is the 3rd step. And then 4th step is conclude your generalization, or yeah, I guess conclude. Conclusion, right? You're going to write down your generalization as a statement, no longer as a thing, but as like a statement. So, I'm going to scroll down here so we have room. I'm going to write this down in green. Any square divided in half diagonally, I know this might seem like it's taking a while, but let's go with it. Diagonally will result in 2 isosceles. Probably spelled that wrong. Isosceles, that's better. Isosceles triangles. And it did, right? So this is a true statement.
Please remember to like, share, and subscribe. And when you subscribe, make sure to hit the notification bell. See you in the next one.